Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 41 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from P&C and probability. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions as a test, you can log into our portal, thegurukul.org.in. So once you log in, you'll come across a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD and VARC. So we will be uploading 100 tests in each section, which you can attempt for free, right? So if you are a CAT 25 serious aspirant, you cannot afford missing those tests. So without any further delay, let's get started with the first question. Now coming to the first question, Ria has 5 red, 4 yellow, 6 pink and 5 white roses. All flowers of the same color are identical. She wants to make a bouquet using at least 3 of these flowers. In how many different ways can she select the flowers? Right. So Ria has 5 red, 4 yellow, 6 pink and 5 white roses, and these 5 red roses are identical, 4 yellow roses are identical, 6 pink roses are identical and 5 white roses are identical. Now let's understand what if there are identical pieces. For example, if I take 4 yellow flowers, if there are 4 yellow colors in front of you, right, now in how many ways can you pick them? Now there is a possibility of picking none of them, one way. Picking one flower out of these 4 identical flowers, in how many ways can that be done? Only one way, because it doesn't matter whether you are picking this flower or this or this or this. There is only one possibility because these 4 are identical, right? Next, if you have to pick 2 flowers, right, again you will be having one way, because picking these 2 is same as picking these 2, is also same as picking these 2, right? So you have only one way of picking 2 flowers, one way of picking 3 flowers and one way of picking all the 4, right? So the total number of ways of picking flowers out of 4 yellow colored identical roses is 5, right? So you have 5 ways. Now similarly, if there are 5 red identical flowers, you will be having 6 ways. 6 identical pink roses, 7 ways, and 5 white roses, 6 ways. So 5 into 6 is 30, 30 into 6, 180, 180 into 7. So 180 into 7. So that would be 700 plus 560, which is nothing but 1260. Right. So there are in total you have 1260 ways. But we are given with a condition here. Right. So she wants to make a bouquet using at least 3 of these flowers. Right. So in these 1260 ways, right, we have some ways where she's not picking any flower, she is picking one flower, she is picking 2 flowers. So we need to subtract those. Right. So 1260 minus. Now in how many ways can we have Ria having what? Ria not picking any of these flowers. So 1260 minus. Now in how many ways can we have Ria not picking any flower? One way plus. Now Ria should be picking one flower. In how many ways can we do that? Now Ria can pick one red colored rose or one yellow colored rose or one pink colored rose or one white colored rose. 4 ways. Right. Now Ria should be picking 2 flowers. Right. Now these 2 flowers can be of same color or can be of different colors. Right. Now if I assume that she would be picking 2 flowers of same color, right, then these 2 flowers can be of red or yellow or pink or white. So you have 4 plus. Now if these 2 should be different, we have 4 different colored roses. So from those 4, she has to select 2. Now what is the value of 4C2? 4 into 3 by 2, 6. Right? So we should be subtracting these. So 1260 minus 10, 10 plus 5, 15. So the answer for this question should be 1245. Now coming to the second question, how many numbers are there between 100 and 1000, both inclusive, such that the units digit is either 3 or 8, but the tens digit is not 5 or 1. So we need to find the number of numbers between 100 to 1000, both inclusive. Right. Now since 1000 is not possible because the units digit is not either 3 or 8, so we should be finding the number of 3-digit numbers. Right. So here we are given with two conditions. The units digit is either 3 or 8. So you can select this digit in two ways. This could be either 3 or 8. Right. And the tens digit is not 5 or 1. So tens digit could be 0, 2, 3, 4, 6, 7, 8, 9. So this could be done in 8 ways. Now coming to the hundredths digit. Now hundredths digit cannot be 0. So hundredths digit can be 1, 2, 3, so on till 9. So you have 9 ways of selecting this digit. So 9 into 8, 72, 72 into 2, 144 should be the answer to this question. Now coming to the third question. In a party, every girl shook hands with 3 boys and every boy shook hands with 2 girls. Also, all the boys shook hands with each other, but none of the girls shook hands with each other. In all, there were 702 handshakes. How many girls and boys were there in all? So let there be G girls and B boys. Now it is mentioned that every girl shook hands with 3 boys. So if there are G girls, the total number of handshakes will be 3G. And it is also mentioned that every boy shook hands with 2 girls, right? So if there are B boys, the total number of handshakes should be 2B. Now, if you observe, these 3G handshakes are between girls and boys, and these 2B handshakes are also between girls and boys. So we are talking about the same handshakes. So I can say that 3G should be equal to 2B, right? Then also, the boys shook hands with each other, but none of the girls shook hands with each other. So there is no handshake between 2 girls, but there were handshakes between 2 boys. So the total number of boys were B. To make one handshake, you need 2 people, right? So if there are B boys, the number of handshakes would be BC2. So you should be selecting 2 people out of B boys. So that can be done in BC2, which is nothing but B into B minus 1 by 2, right? Plus, you have handshakes between boys and girls. How many? 2B, right? So let me try to frame a single equation in terms of B. Now this is given to be 702, right? Then what do we have? B square minus B plus 4B is equal to 1404, or B square plus 3B minus 1404, this should be equal to 0. So we need to write 1404 as a product of two numbers such that they add up to plus 3, right? So that should be, I guess, 39 into 36, right? Because the perfect square close to 1404 is 1600. So these two numbers with a difference of 3 should be close to 40s, right? And should end with 4. So 9 into 6 is 54. So I guess the number should be 39 and 36. So B square plus 39, 39B minus 36B minus 1404 is equal to 0. Now I can write this as B plus 39 into B minus 36. Now this is equal to 0. Now B has to be minus 39 or 36. Minus 39 is not possible. So there are 36 boys. So if there were 36 boys, 2 into 36, 72. 72 is equal to 3G. So there should be 24 girls. Now what was asked? How many girls and boys were there? So 24 plus 36. There were a total of 60 girls and boys. So the answer for this question should be 60. The number of ways in which one can put 3 balls numbered 1, 2, and 3 in 3 boxes labeled A, B, and C such that at the most one box is empty. Now, what is the meaning of at the most one box is empty? So you can have at max one box empty. Ante 0 boxes empty or exactly 1 box empty, right? So you have 3 different balls numbered 1, 2 and 3, and 3 different boxes named A, B and C, right? So let me try to fill all the 3 boxes. So placing one ball here, one ball here, one ball here, right? Now in how many ways can I select this ball? 3 ways, and this ball in 2 ways and 1 way. So in total there are 6, right? Now the other possibility could be 2, 1, 0. Now first what should I do? Out of these 3 I have to select 2 balls, so that can be done in 3C2 ways, which is 3, right? Then once we have 2 balls, we will be left with 1 ball. So we have selected these 2 balls, we are left with 1 ball. Now you need to arrange these 3, right? So 2, 1, 0 can be arranged in how many ways? 3 factorial ways. So 3 into 3 factorial, 18. So in total you have 24 ways of arranging these 3 balls in the boxes named A, B and C. Now coming to the next question. A speaks truth in 70% cases and B in 80%. The probability that they will contradict each other when describing a single event. So when can we have A and B contradicting each other? So one of them should be telling truth and the other should lie, right? So there are 2 possibilities. You can have A speaking truth and B lie, or A speaking a lie and B telling truth, right? Now what is the probability of A telling truth? 70%. So 7 by 10 into probability of B speaking truth is 80%. So what is the probability of B not speaking truth? 20%. 2 by 10 plus A lying. A speaking truth is 70%. A lying 3 by 10 into B speaking truth 80%, 8 by 10. So you have 100, 7 into 2, 14, 14 plus 24, 38 by 100, 0.38. Hence option B should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share and subscribe.